Hello guys!
Oh, hello.
It's been a very long time since I've seen all of you, really. So I don't know when it's the last time I was able to be with you, probably 6-7 years ago or so. So, I don't know what the program is. Yeah, I might have missed something. Maybe I was supposed to prep something which I didn't. In that case, I'm really sorry, and I'll try to improvise. I don't know how much time we have.
You've got. Oh, sorry. You've got half an hour, Cyril. If you want. If you wanted to talk about the 12C, that you just give a quick overview of what you talked about in the book. And then, remember about replatforming the 12C? And then maybe we'll talk about the prime, yeah?
Okay. So the 12C, of all the calculators, it's the one with the longest history. And I'm trying to see if I can find mine around. 1 second.
It's it.
Here's mine. Here's one of mine, which was, I think, a commemoration of the 1 millionth 12C shipped at the time. So the funny thing is, when I started in HP, one of the ongoing projects was a 12C redesign. So that would have been in '98 at the ACO in Australia. Hey, can you please mute it when I'm talking, because I get lots of echo, and unmute when you're asking questions, so because it's really hard for me. So yeah, so the 12C was an ongoing project when I joined the calculator division in Australia with a team working with some university in Australia to redo the microcontroller because it couldn't be made anymore, very, very old technology. They basically had to recreate it in more modern technology. At the time we were probably talking about a couple of micron type thing, maybe 5 micron, 10 micron, which at the time was pretty good. And so there was a team doing that, and the aim was just to recreate the microprocessor as is to continue producing 12C. So that would have been 2000. And I think at that time there was a change of the battery because the old TTL or the old CMOS technology was moved on to more modern systems. And then not much happened. Except that the production was done by the part of HP that split up and became Agilent, and now I think it's Renesas. I don't know. I have not followed what happened there. And at one point, so if you remember, the ACO closed in 2000, end of 2001, early 2002, and nothing much happened for a couple of years until Agilent say, hey, we're not making your old stuff anymore, deal with it. And at that time, I was the R&D team because there was only me in the calculator division. And I don't remember if it was kind of the same time we did the 50G and all the Apple series, the new 50, 49, 30, 39 type things. And I had to figure out a way, and at the time we were doing emulators everywhere because, of course, the Apple series was, running the 48 on an ARM chip. So I started working and I started looking for CPU, and I found that French company Atmel, which now in between has been purchased by, I don't remember who purchased them. But anyhow, I started working with them as I was looking for companies who had microcontroller we could use. And the thing is, they were looking at designing a new microcontroller at the time based on an ARM7 TDMI.
And we were also thinking about what became the 20B, 30B, 40B series at the same time. And so I work with them to design that microcontroller, that SAM7L, if I remember well the name. And you know, that was supposed, as I say, it ended up being used in the 20B and also in the 10B2, and of course in the 12C. And then came the problem of, okay, now we have a microcontroller, we need to emulate the old NUT CPU from the 12C. We need the ROMs, also, which we did not have. Didn't have the ROM, didn't have, I think I had like a 2-page documentation on the microcontroller. That's it. You know, maybe 4, maybe 2-page. You know, it was an old typewriter written thing, which had been copied 5 times and scanned at some point, and that's all I had to work with. Luckily, the NUT isn't that different from the Saturn chip, from the 49 or 48, which of course I was slightly familiar with, to say the least. And I had to kind of reinvent an emulator. Of course, Eric Smith had his NUT emulator, but since that was open source, I was told by the whole legal department, you cannot look at that source code because then our code will be tainted, and we wouldn't be able to use it without open sourcing everything. Blah blah blah. So I couldn't look at Eric's stuff, which was very problematic. So my first task was to try to figure out, you know, can I emulate the old 12C? And I started with a very quick emulator in Delphi. I actually probably have it somewhere still in my archive, but in Pascal, basically, which was my language of, you know, my go-to language for fast stuff at the time. So I started trying to make an emulator for the 12C in Pascal. And the emulator was doing everything, not only the emulation, but also decompiling the ROM at the same time, giving me traces, allowing me to put breakpoints, allowing me to see tight loops, to find pauses. And I mean, I got a lot of things working pretty much on within a week. But there was stuff that just were not working because of weird things, bugs in the nuts. And that's why I contacted Eric Smith and I say, look, here's what's happening. I can't look at your code. I know my emulator has some issues somewhere. Here's one chunk of code, for example, where I have a problem. It's not working well when I press on that key after doing this, and that. Can you modify your emulator so that it generates traces logs of every instruction emulated? So that I can compare what it's doing compare with mine. And Eric was really nice, and I don't know if he's in the audience here today, but Eric was really nice and actually worked with me and made modification to his code and gave me some, basically debug information, I don't remember if he gave me an executable that I could just play with. And that helped a lot to do pretty much everything. I think one place where I had to ask him a technical question, there's a bug somewhere and I don't remember what it is in the NUT. And he told me, oh yeah, here there's a bug and you need to handle it differently. And here's the trick to do it. So I did that. So that was the first part of the 12C, getting it working. Then I started having to translate that into the hardware. So of course, I mean, I had raw hardware, so I had to build a little micro operating system, which is really interesting on the ARM7 TDMI because it basically reboots in between each key press. That chip was really super power efficient, at least for the time. You could have the LCD running on the side, the memory being kept or not, and power off everything else. The whole CPU would go down. I mean, it would completely go down. A register lost everything, but you could get it to restart on a key press, and it would restart in a blink of an eye. So in between each key press in that version of the 12C, the CPU turns off. The whole SoC turns off, except for the LCD and the keyboard detection and a timer. And that is absolutely it. Which means that every key press it has to reboot and the memory. Every key press it has to reboot really quickly, handle the key press, and go back. And so I started making multiple versions of the emulator, some which are very small in size, kind of the way you do it by hand. But that really, that does much more tests and whatnot and loops. And then I use that version to actually generate the source code of an emulator that has every single instruction as a single separate procedure or function. And then I even got rid of the function, basically doing one big, the equivalent of one huge switch case for the 2,000 or 3,000 or 8,000 instruction. I don't remember. It's 12 bits, so that would be 4,000 Ks of instructions. Basically one big switch case with every instruction is unrolled completely. There is no loop whatsoever in that thing. And the first time I got it running, I started pressing on keys, and of course you just get the answer. That's normal. And then I tried to do, I think, an I percent calculation or maybe a reverse IRR, which were operations that could take minutes on the 12C. And it came back instantaneously. I'm here, okay, I must have a bug somewhere because that doesn't sound right. And then I look at the result and it's correct. I mean, okay, let's try that again. And I tried 2, 3, 4 calculations and they all came up correct in a blink of an eye. And I'm here. I really couldn't believe the code was that fast, but it was, and it is, and it's, it was great work there. There was lots of other little things that I had to do. For example, I had to patch things like the loop. When you got pause instruction or similar, the whole node code was just looping for 1 second. Here, that is so memory, power inefficient. Let's be ecological. 15 years ago, I was trying to conserve microwatts out of that thing, but I was thinking of battery life too. So these were patched with a special new instruction that would fall back to the real hardware and do a low power pause. And so that was the first 12C. And the same OS or the same OS part of things was used also for 20B, and then later on for the 30B, of course, and the 40B that never came out, and the 10B plus, the 10B2, when the 10B2 microcontroller died, the same hardware, the same OS was reused, but then it's Tim who did the software part. So that was the SAM7L 12C. And then, of course, that microprocessor got end of life, and that was 7, 8 years ago. And I had to find yet another microcontroller and ended up with, I think it's a NXP or something like that. And it's a Cortex 4. No, Cortex M4 or Cortex M0? Don't remember. M0 maybe. No, it's a Cortex M4, I think. But there, I mean, the emulator, I already had pretty much all of that. Had some issue with the blinking. If you take the new 12C, I know there's some bug related to screen blinking because the old SAM4L, so SAM7L, has built-in blinking for the LCD, which I could just reuse. But there I had to emulate it in software for the new one, and I didn't have the reboot every time thing. So the OS part I had to redo, but that wasn't too much of a job to make work. And that's the current 12C until the CPU goes EOL, probably with 6 months warning tops. And at that point, I'm assuming somebody is going to be saying, "Oh my God, we need to, do something," so that the 12C can continue being produced and sold for the next 40 years or so. And of course, we had the 15C renewal with the SAM7 hardware. lucky enough, since I got all 4 ROMs, and I honestly don't remember who from your group. I mean, we got the ROM back from someone like Eric Smith or somebody else within the Calcutta enthusiast groups. That's what saved us. Else we would not have been able to make these calculators. So. Well, that's a little bit, that's basically all for the 12C. That's kind of all I remember. It was a fun, they were fun projects. As I said, somebody's going to have to do it again, and it might be me by the time the current CPU ends of life. But we've sold a lot of the 12C. I really wish I knew exactly how many were sold since the 12C was first released. And somebody can probably tell me exactly when that was, probably in 76 or something that I don't remember. I was 2 years old in 76. So, but yeah, that's basically it for the 12C. As I say, I got Kinpo. I don't know, Besta gave me a nice one in a nice package, nice, what's it called, polycarbonate presenter one. I also have, we did an anniversary edition at some point, which ended up in a really super fancy box, and I've got the one with serial number 12. And I got the same thing for the 15C with the serial number 15. I asked for them specifically. So these, are here with me. One day they'll be collectors. I guess they already are. But that's basically it. So kind of it for the 12C and my memories of it. So if you have questions, go ahead. I'll be answering them. Try to speak really clearly and distinctively.
Thanks, Cyrille. Hopefully you can hear us. Somebody said 1982. Was it for? No, it's just Voyager was before that. Right. So Chuck made the chips, designed the chips for the 12C, and he's in the audience. And we saw some of those yesterday. So that was 82 for the Voyagers.
So I was 6 years old.
I have a question. I don't know if you can see me over the corner here. Did I understand that HP did not have the ROMs? You had to get them from the enthusiast community? Is
that? When somebody asks a question, can
I'll repeat it. Yeah, sure. So
I understood it, but barely. So
yes. So Robert's asking that. Did you say that you had to get the ROMs from the user community because HP hadn't got them?
Correct. That is correct, and that is not the only time. When we restarted the calculator division in Australia, we did not have the source code for the 48 either, the 4838. And somebody who I will not name, who had left the HP calculator division a couple of years before, and who was now working for TI in the calculator division, which means that pretty much every one of you now know who that is, had a completely illegal, by company standard, personal copy of the source code of the thing on which, she spent years of her life and gave it back to us so that we could restart work and did the 49, 39, 40 series we are based out of. Luckily enough, engineers tend to keep personal copy of the work they've done for companies instead of keeping it in the official storage vaults of the company, which means that when it's needed 5 years later, 10 years later, the data is available because the company has lost it. If I wasn't there and if I had not been there working for the HP calculator division for 20 plus years, all the data I have would be lost. I mean, it's technically backed up on some system, but the system do not exist anymore. The backup do not exist anymore. Even if they did, nobody would be able to locate them, find them, unzip them. They're probably backup of system running on whatever God knows what hardware and needed some version of HPUX which does not exist anymore. So even if the backup could physically be found, the data could not be had. I had a discussion at one point with my manager who was working with some company who was trying to sell some backup system, and the manager said, "Okay, come with me because I don't want to be techno babbled." And I sat through the presentation from the sales rep about his backup system and his great backup system and the best backup system in the world. And I'm here. Okay, we don't care about a backup system. We want a restore system. If you don't have a great restore system, you have shit nothing. And the guy was just, yeah, I don't care about backupping. I want to restore. And so many backup systems rely on a whole infrastructure to restore. And if the infrastructure is not there, you can't restore. And that's the case of so much of the work I've done, which rests in some HP systems, which are not restorable, which is why I have a backup copy. And the day I leave HP, technically I need to erase the data so that it stays at HP because it's HP's data. Obviously, because I'm an engineer, I'm gonna keep a copy, and one day some poor bugger, sorry for the Australianism, will be coming to me and say, "Hey, wouldn't you happen to have a copy of that? Because we can't find it internally." At which point I say, "Yeah, here it is." So we got the 48, 39, or 38 source code back from all the engineers and the community. I think we got some version also from TDS, who had, for some reason, a copy. We got the 12C, 15C, 11C, 16C ROM from the community, 10B2 ROM. I mean, every single ROM we have, we got them back from you guys. Documentation, we got better documentation from you guys than internally from HP. Because you guys care and keep the data, companies don't know how to handle that. So,
thanks,
long
Cyrille.
answer.
I think that we should have a show of hands as to how many people have experienced the same thing, because I have. Yeah, that's everybody. Okay. So
there's one thing I'd like to say. Officially, of course, we never keep copies of any work we do in companies.
No, absolutely.
It just happened that we forgot to remove them.
We forgot that we have an off-site backup. Yeah.
Yeah.
Just question on the Prime, if I may. I know Moravia talked about it yesterday. Klaus talked about it yesterday. Are you presumably you have the development systems for those, and is that being handed over to them? Are you helping them with the source, and are you, or is it just they are working on it now?
Yes.
Thank you.
All of it. No, I mean, yes to all of it. That's what the simple yes means. Do I have the development system? Yes, of course, I have it. The repository has been moved over to a Moravia control server. Do I have a dump of the latest revision? Yes, I do. Because sometimes they say, "Oh, we have a bug there. Somebody's reporting something. Can you tell us what's happening?" To which point I can go and say, "Okay, you have a problem there that needs to be fixed." So Moravia has it, and they have at least 2 persons on retainer to work on it. 2 persons that I mean, there were 4 persons working on Prime. The 4 of us, 2 of them working at HP, 2 others not working at HP. And as far as I know, they're working with Moravia and they have all the access. They still come to me when they have a bug which is not CAS-based, basically, saying, "Hey, what's that all about?" Because they know I'm the fastest one to be able to tell what happened. If it's really simple, I can fix it on the fly. If it's not very simple, I give instruction and somebody else works on fixing it. And they have the development environment and they can do it. So it's the contract between Moravia still has some technical support by HP or provided by HP, and that technical support is me. So yes, I am still involved. I still help. I still have access, and until they decide otherwise and tell me, okay, we need you to disengage completely. I will have it. After that, I will of course delete all my backups, because I do what I'm told, and forget one somewhere, because that's 10 years of my life or so in the prime development, and there's some cool code there, and one day I might want to show it to my kids. But I'm a good person and I'm not going to do something bad with it either. But maybe that in 30 years from now, somebody would be happy to find it.
Yeah, absolutely. Thank you. Anybody got another question? I think we're done then. Oh, Jake, sorry.
Are you still making telescopes?
Are you still making telescopes, Jake asks. I can see them behind you, so we're in the telescope lab.
Yeah, I've got a couple here. I guess since you're in Britain over there, that's one of the funny one. When you look in a telescope, you can see the whole world. So it's kind of bigger inside than outside. So I have a telescope. For those of you who are, familiar, who likes Doctor Who, what else do I have? The interesting ones around here. Oh, that's a funny. Yep, that's a funny little one, and I'll try to stop moving to get a good picture. But you've got basically a ball mount here, and I mean, it's very much empty. There isn't much, but there's just enough surface here, enough linear space to create a virtual ball and to be able to point that thing. So that's kind of interesting, and it's all, I made the pieces. I created the mold, sand mold, and cast them myself. So that was pretty much quite some work. More mathematical in nature. I've started making, and I'm coming back here, I'm just grabbing stuff on the side. And I mean, since it's kind of a British invention, Lord Orrery is known for, orreries, which are representation of the solar system. Kind of funny because there's all the math for the cog work, which is kind of a pain in the butt to do. But that was fun to do that. I've got a little laser cutter that I paid $200 for, so that allows me to do this type of thing. But I also made one of an extrasolar planetary system, in that case TRAPPIST, which is like 20 light years away from us or something like that. So, other thing linked to astronomy, but yes, I'm still very much involved in telescopes and telescope making. I'm actually president of one of the local observatory around here, so I've got access to some nice material. So yeah, I do some telescopes. I probably have 10 of them behind me. I'm sorry, I know, it's kind of a mental problem I have with gathering bunch of technical equipment and keeping them at home. I mean, you see some of them here. There are more telescopes over there too, in my little office. I wish there was some type of group or society where one could discuss the compulsory need to hoard old stuff and play with them and tinker with them, but I don't know if that exists.
Maybe, yeah, we're here. Thank you, Cyril. Anybody else, any more questions? Jake again.
Well, since the question had come up before, I just thought I would mention, I've got the issue of keynotes here, volume 5, number 3, where they list that on September 16th, 1981, the 11th C and the 12th C were introduced.
Very good. Did you get that?
No, absolutely not.
Jake was looking at the keynote when the 11 and 12C were launched, which was September 16th, 1981. There you go. Super. Right. Are we happy? Thank you very much, Cyrille, for joining us, and say hello to your family.
I will. On a more personal note, Vlodek, I'm assuming Vlodek, you're on the side here, which is why I can. Oh, you're over there. As you can see, there's still something missing on my arm, on my wrist.
Don't say again. You only get that if you come to the UK, Cyrille.
I know, and I really was looking forward to be able to be here today, but my father is turning 80, well, just turned 80, and we were celebrating as a family yesterday, so I was kind of stuck here. So it's, unfortunate, but I couldn't be there with you. I would have liked to. And then there's a problem, of course, with HP disengaging, there's no budget or whatnot, so I'll have to do it partially on my own. Although Moravia did propose to pay for my trip this time, and I don't know if class is there, but thank you very much for that. Unfortunately, it's, I couldn't make it happen for family reasons, so I'm really sad about that.
Still waiting for you. It is still waiting for you.
Yeah. Klaus had to dial in as well, unfortunately, but hopefully we'll see you again soon, both of you. Yeah. Okay. Everybody happy? Thank you very much.
Thank you. It was really, really, really nice to see some of the faces over there, even if the video was not always great. I recognize lots of you, so it's really heartwarming to see you again, and to see you all, there after all these years that we've spent together. So.
Thank you. Okay. Take care, Cyrille. We'll see you again soon.
You too. Bye.